Welcome to the session 4 of module 1. In this session, we are going to study about 4 and 5 variable K-map. These are the contents that we are studying in this session. 4 variable K-map. We are solving some examples on this 4 variable K-map. 5 variable K-map. How to write a 5 variable K-map and how to write a K-map of 5 variable function, and we'll solve some examples on this 5 variable K-map. 4 variable Karnaugh map. We know how to write the K-map for the n variable function. For the 4 variable function, we should have 2 power 4 number of squares, 2 power 4 number of squares in the K-map. 2 power 4 is equal to 16 cells we should have in the K-map. The rectangular diagram should be divided into 16 squares. Should be divided into 16 squares, 4 rows and 4 columns. The Karnaugh map is matrix of squares, where for the 4 variable function, we are dividing the rectangular diagram into 16 squares. 2 variables for the rows and 2 variables for the columns. It is symmetric. Okay, we are having 2 variables for the rows and 2 variables for the columns. The basic concept of labeling the variables and writing the minterms in the squares remains the same. Adjacent cells differ in the value of a single variable. We are using the law that is a plus a bar is equal to 1, which means that we should have an adjacency between the cells. The cells should vary by only one variable. It should vary only by one variable. Okay, so we can eliminate the variable which is in the form of a plus a bar. Okay, since a plus a bar is equal to 1. Variable plus its complement is equal to 1. Top, bottom and left, right cells are also considered adjacent. We have studied in the last session the K-map rules and the steps to follow while simplifying the expression using the K-map. The 4 corner cells are considered adjacent to each other. These are the rules that we have to follow while grouping. Okay, the basic concept of labeling the variables remains the same, which we did for the 3 variable K-map. This is the 4 variable K-map. We are having total 16 cells. The minterms ranges from 0 to 15. And we are writing the minterms in such a way that the binary values for the rows and columns are decoded into a decimal value. And here we are considering the binary weight of each of these terms, each of these variables. Okay, whenever we are considering 0, 0, 0, 0 for the w, x, y, z, which means that 2 power 0 into 0, 2 power 1, 2 power 2, and 2 power 3. That is 2 power 0 is 1, 2, 4, and 8. The binary weighting we are considering in order to write the decimal value in the cell. 0001, 1, 0011, 3, 0010, 2, 0100, 4, 0101, 5, 0111, 7, 0110, 6, 1100, 12. Why we are considering 11 here? Because here 01 is adjacent with this 11 because only w variable is changing in these two terms. If you are writing 10 here instead of 11, if you are writing 10, here we are having 01. Both w and x are varying here. Both w and x are varying. So We cannot eliminate any of these two variables, W and X. We are writing 1, 1 here and 1, 0 here in order to have an adjacency between the cells. Okay, you have to remember the numbering of this Wx and Yz, that is MSB bits and LSB bits for the 4 variable key map. Okay, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And by having the binary weighting for each of these binary values, we can write the equivalent decimal value for each of these squares after decoding it decimally. Okay, 7, 6. Here after that, 1, 1, 0, 0 is 12, 1, 1, 0, 1, 13, 1, 1, 1, 1, 15. Okay, 1, 1, 1, 1 means all the variables we are having. Okay, 1 plus 2, 3, 3 plus 4, 7, 7 plus 8, 15. Next, 1, 1, 1, 0 is 14. 1, 0, 0, 0, 8. 1, 0, 0, 1, 9. 1, 0, 1, 1, 11. 1, 0, 1, 0, 10. Okay, in this way, we have to write a 4 variable key map. The 4 variable key map is having the symmetry. Okay, we are using 2 variables for the rows and 2 variables for the columns. We'll take one example of how to simplify a 4 variable function. Simplify k equals f of wxyz summation 0, 1, 4, 5, 9, 11, 13, 15. What is the first step? We have to know how many cells should be there in the k map. How many variables are there here? 4 variables are there. So how many cells we should have in the k map? 16 cells. Okay, we have to write 16 cells in the rectangle, and then afterwards we have to write the MSB and LSB bits, and then binary values. Instead of binary values, we can also write the variables. In terms of variables also, we can write W bar X bar, here W bar X, WX, and then WX bar. Here we can write, here also we can write the variables, that is Y bar Z bar, Y bar Z, YZ, and YZ bar. Okay, we can write either the binary values or the variables. Okay, first step is we have to write the k map with 2 power n number of cells, where n represents the variable. After that, we have to write the MSB and LSB, and we have to write the binary values for each of the rows and columns. We can write either binary values or equivalent variables we can write. And after that, we have to write the decimal notation for each of the midterms. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This you have to remember. Okay, in the 4 variable k map, if you are not writing 1, 1 here, then we cannot eliminate the variables. Okay, if you are considering 1, 0 here, because these 0, 1 and 1, 0 is not adjacent. So we should not write 1, 0 here. We should write 1, 1, and afterwards for the next row we have to write 1, 0. Next, here we have to check for the larger number of ones, larger group possible in order to get a product term. We are having the minterms 0, 1, 4, 5, which makes one quad, which forms one quad, and we are able to eliminate 2 variables. Okay, 2 power 2 is equal to 4. If you are grouping 4 cells, then we are able to eliminate 2 variables. And what we get here after grouping the 0, 1, 4, 5, we get the simplified expression, that is W bar Y bar, simplified term. Here from these 2 rows, we are getting W bar term, And from these two columns, Z is changing from 0 to 1. So we are eliminating Z and we are having Y bar. W bar, Y bar. So we are getting W bar, Y bar when we are when we are grouping the min terms 0, 1, 4 and 5. Next. Here next other min terms we are having is 13, 15, 9, 11. We have group 0, 1, 4, 5. The remaining min terms we have to group is 9, 11, 13, 15. When we group this 9, 11, 13, 15, from these two rows, we are getting W as common term, but variable X is changing from 1 to 0. So we are eliminating X here and we will get W. And from these two rows, because these min terms belongs to this row, okay, each min term will be written by considering the binary weights of these variables w, x, y, z. So this min term belongs to this min terms 13, 15, 9, 11 belongs to this columns. So the term we are eliminating here is y and the term we are getting here is z. So we are getting a product term wz when we group 13, 15, 9, 11. Okay, wz. Next, if you want to write all the prime implicants, then we have to group this 1, 5, 13, 9 also. Okay, 1, 5, 13, 9, which gives us y bar z. Since here wx is changing, it's changing from 0, 0, 0, 1, 1, 1, 1, 0. We can eliminate this wx. Okay, we can simplify this expression and we can eliminate this wx. How we can eliminate? Here from these two rows, that is 0, 0, 0, 1, we are eliminating x variable and we are having w. From these two rows, we are eliminating x and we are here we are having w bar, here we are having w. After we check these w bar with w, it is changing. So, which means that whenever we are grouping 4 ones, okay, 4 ones, if both the variables are varying, then we can eliminate those two variables which are varying and we can have the variables which are common, that is y bar z. Okay. Next, the final expression we can write is the expression should contain the essential prime implicants. But here, this y bar z is not essential because this min term 1, 5 is combined with 0, 4. Min term 13, 9 is combined with 15, 11. So we can no need of in considering this y bar z in the final expression. The final expression can have wz plus w bar y bar. Okay. If they ask you to write all the prime implicants, then we can consider this. Okay, if they are telling us to simplify the expression, then we have to write this one. Okay, we should not have redundant terms in the final expression. Next example, simplify p is equal to f of w x y z summation 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. First step is we have to check how many variables are there in the function. 4 variables. How many cells we have to write? To power 4, that is 16 cells we have to write in the key map. 4 variables to power 4, that is equal to 16 cells in the key map. We will write a 4 variable key map with 16 cells. After that we have to write the LSB and MSB bits. This is MSB and this is LSB bit. After writing MSB LSB, we have to write the binary values for each of the rows and columns. After writing the binary values for each of the rows and columns, we can write the decimal equivalent of those binary values. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 3, 0, 0, 1, 0, 2, like that. Okay, we are writing the min terms in the cells or squares. After writing the min terms decimal notation in the cells, we have to write the logical highs for the respective min terms which are present in the equation. The min terms 0, 1, 2, 4, 5, 6, 8, 9, and then 12, 13, 14 are having logic highs. We are entering the logic highs in the key map for the min terms which are present in the SOP. After writing the min terms in the key map, which are logic high, we have to group it. First, what we have to think? We have to think which is the largest group possible here. Which are the min terms which are adjacent with more number of logical ones. We have to consider the cells with logical highs. Okay, but we have to do the larger group possible. Here 0, 1, 4, 5, 12, 13, 8, 9 are larger group possible, okay, where we can group 8 number of cells. This makes one octet and we are able to eliminate 3 variables from this group. So what is the term we will get here? Okay, here all the variables are changing here, that is WX variables are changing. From these two columns, here Z is varying, we will get Y bar. Okay, this octet gives us the term Y bar. We are eliminating other variables WX and Z. Okay. Next we are left with the min terms 2, 6, 14. If you are grouping it as a pair, we will get extra variable here. Okay, we are able to eliminate only 2 variables when we are making a pair. So this 2, 6 min terms, are adjacent. These 2, 6 min terms are adjacent to 0, 4 min terms. 2, 6 min terms are adjacent. Okay, we have studied the key map rules where when we wrap this table or fold this table, the leftmost and rightmost cells are adjacent to each other. They are logically adjacent. Okay, so we can group this 2, 6 with 0, 4, which gives us W bar, Z bar product term. Okay, here W bar is common. We are eliminating X. And here in these two columns 0, 0 and 1, 0, we are eliminating Y and we are getting Z bar. So we will get the term W bar, Z bar. Next, which min term is left over? Min term 14 is left over. Min term 14 is left. Now, here this min term 14, if you are grouping it as a pair, you will get extra 1 variable here. Okay, 3 variables you will get. You can eliminate only 1 variable if you are making it as a pair. Okay, this min term 14. When you are grouping this 14 with only 6, we will get Y, Z bar, and from these two rows we are getting X, Y, Z bar. But if you are making it as a quad, we'll see what happens. When we group this 14 with 6, 4 and 12, we will get XZ bar as a product term, okay, which is a simplified term when we group 6, 14, 4 and 12. Now the final expression is w bar z bar plus xz bar plus y bar. I am including all the terms. Why? Because all are essential prime implicates. This min term 0, 1, 4, 5, 12, 13, 8, 9. Min term 1, 5, 39 are essential min terms, and the product term which I am getting here is essential prime implicant. Next, 0, 4, 2 and 6. This 2 is combined with 0, 4 and 6, which is combined in only one way, okay, which cannot be combined in any other way. So this term is also essential prime implicant, okay, which is this min term 2 is unique here. Next, for this implicant xz bar, okay, here min term 4 is combined in only this way. It cannot be combined in any other way. So this xz bar is also essential prime implicant. So we have to include all these three terms in the final expression. Okay. Next, we will solve this example. Simplify the equation r equals f of wxyz summation 5, 7, 8, 9, 13. Here, first step is we have to write the K-map with 16 cells. After that, we have to write the MSB bit and LSB bits. And we have to write the binary values for those. And we have to enter the decimal notation in the squares. After doing this, we have to write logical highs for the respective min terms which are present in the expression, which are present in this expression. Which min terms are logic high? 5, 7, 8, 9, 13 are logic high. Now we have to group this min terms with a larger group possible. Can we make it as an octet? No, because no 8 min terms are present here which are logic high. Next, go for quad. Is it possible? No. No 4 cells are adjacent here. Next, go for pair. It is possible. We have to think how to group these min terms. Okay, we should not have redundant terms. We can make this 5, 7 as one pair. Okay, and we can make this 5, 13 as another pair, 8, 9 as another pair, and 39 as another pair. Total 4 pairs I am having. 4 pairs I am having. But which is essential prime implicant? All these 4 implicants are prime implicants. Okay, this 8, 9 grouping, 13, 9, 5, 13 and 5, 7 all are prime implicants. But while writing in the final expression, we should have only the essential and the terms which are not covered in that essential prime implicate, we have to consider in the final expression. Here, when we group this 8, 9, what we will get? The term W, X bar, and then from these 2 columns we will get Y bar. Okay, next. Next, what I am getting? I am getting when I group 13 and 9, I will get W, and from this column I am getting Y bar Z. Next, when I group 5, 13, when I group 5, 13, which term I will get? I will get from this, when I group these 2, 5 and 13, I will get X and then Y bar Z. When I am grouping this 5 and 7, I am getting W bar, X, and then Z. These are the 4 prime implicants, but for the final expression, we have to include only the terms which are redundant. Okay, we have to remove the redundancy, and we should have the simplified expression. Okay, and here R is equal to Wx bar y bar, W y bar z, X y bar z, W bar X bar z. The final expression, we have to consider the simplified expression, and we have to remove the redundancy. Okay. Now, we have to consider this 8 and 9 because 8 is unique. Okay. Because 8 is unique, we have to include this term. Okay. We have to include W X bar Y bar. Plus, next, this implicant 7 is unique because it is not combined in any other way. So we have to include this term. Okay, this term, this product term, that is what we will get. We will get W bar X and Z. Okay, plus we have to include this W X bar Y bar and the other term W bar X Z. W bar X and then Z. Next, we have covered this 8, 9, 5 and 7. The term which is left over is 13. Okay. So, we have to consider either of these two. 13 is grouped with 5 also and 9 also. So, we can consider either this or this in the final expression. If you are writing both WY bar Z and XY bar Z bar, which is redundant term. So, we should remove that redundancy. Okay, and then here for the final expression, we can write W X bar Y bar plus W bar X Z. Along with that, we have to write WY bar Z or XY bar Z. Okay. Next is 5 variable K-map. How to write the 5 variable K-map and how to solve the 5 variable function. This 5 variable have 32 minterms and K-map must contain 2 power 5, that is equal to 32 cells. We know that the K-map should have 2 power n number of cells, where n represents the number of variables in the function. If you are considering 5 variable function, 2 power 5, that is equal to 32 cells we should have in the K-map. Okay, and which ranges from 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1. Okay, this 5 variable K-map is made using 2 4 variable K-maps. If you are going for whole 32 cells in the K-map, it is difficult to visualize. So we can write a 2 variable K-map with vertical alignment, okay, which is easier for us to visualize. And this 5 variable K-map can be made using 2 4 variable K-maps. 2 4 variable K-maps. 5 variable K-map can be constructed in 2 ways. One is mirror image version and the other one is stacked numbering version. In the mirror image version, we are writing the mirror image version like this. Okay, we are considering 2 variables for the rows and 3 variables for the columns. Okay, 3 variables are laid horizontally and 2 variables are vertically. Okay, and the minterms are decoded. Okay, the binary values that we are having for 5 variables are decimally decoded and written in the minterms. Okay, in each of the squares. Where A, B, C, D, we are having 5 variables, A, B, C, D, for example, and A will be having 2 power 0, D will be having 2 power 1, C will be 2 power 2, B will be 2 power 3, and A will be 2 power 4. Okay, these binary weightings are added, and after addition of these binary values, we are getting the decimal notation of those. Okay, each of the minterms or each of the squares are decimally decoded. Okay, according to the binary values we are having for the rows and columns. And this is the numbering of the 5 variable K-map, which is mirror image version. Okay, here we are writing the MSB bit for the rows and LSB for the columns. Okay, MSB is laid out vertically and LSB horizontally. Okay, 0 0 0 0 0 0 0 0 0 0 0 1 1 2 3, and then here 0 0 1 0 0 is 4. Why we are writing 1 0 0 here is these 0 0 0 and 1 0 0 0 are logically adjacent. Okay, we are considering it as a mirror image. When we fold this when we split here, okay, at this point, we can look these two as separate 2 4 variable key maps. Okay, and if you are folding at this point, then these two are mirror image. Okay, these 0 1 0 and 1 1 0 are adjacent. 0 1 1 are 1 and 1 1 1 are adjacent. 0 0 1 1 0 1 are adjacent. 0 0 0 and 1 0 0 are adjacent to each other. Okay, when we fold these 2 4 variable key maps at the point 2 6 10 14 26 30 and 18 22. Okay, this minterms 0 and 4, those columns are adjacent, and the minterms starting from 1 and then 5, those two are adjacent, and minterm 3 and 7, these columns are adjacent, and these 2 and 6, these minterms, these columns are physically adjacent and also logically adjacent. Okay, so this mirror image version of 5 variable K-map, we are having total 32 squares in the K-map. 3 variables are laid out horizontally and 2 vertically. And we have to remember the numbering of this. Otherwise, we can remember the adjacency of the cells, and then we can do the write the K-map. Okay, here we have to write 110 because we have to have an adjacency between the cells. When we have the adjacency, only one variable should change between the cells. One variable should differ in both the cells. So this minterms of these columns are logically adjacent and also physically adjacent. These columns 3 11 27 19 7 15 31 23 0 1 1 and 1 1 1. If you see here, okay, only one variable is changing. Okay, so these two are adjacent, and these two columns 0 0 1 1 0 1. Okay, these two columns, only one variable is changing, that is C is changing, other terms D bar E remains same. In these two columns 0 0 0 1 0 0. Okay, only one variable is changing, other two bits remain same. So in this way we are finding the adjacent columns in this 5 variable mirror image version K-map. Okay, in this mirror image version of 5 variable K-map, physically adjacent column is also logically adjacent. Logically adjacent columns occur as mirror images. Each half of the 5 variable K-map corresponds to a single 4 variable K-map. Okay, each half of the 5 variable K-map is considered as a single 4 variable K-map. Next, stacked numbering version of the 5 variable key map. In the stacked numbering version, okay, we can see that the right half of the map is sliding over the left half of the map. Right half of the map is sliding over the left half of the map. Here the column adjacencies are as indicated in this figure. Okay. This is the stacked numbering version of the 5 variable key map, which is different from the mirror image version numbering. And here 0, 1, 2, 3. Here we have to write 4, 5, 6, 7. There we were writing 6, 7 and then 4, 5. Okay. But here we have to write like this. Numbering should be like this. Here also the 3 variables are considered are laid horizontally and 2 variables vertically. Okay. And here we have to number like this 0, 1, 2, 3, 4, 5, 6, 7. Since we are sliding over the right half of the key map is sliding over the left half of the key map. Okay. When we place this key map 4, 5, 7, 6, 12, 13, 15, 14, 28, 29, 30, 31, 20, 21, 22, 23. This key map on this left key map, the left half of the key map, okay, which we can visualize it as a stacked version. Okay, we are placing one 4 variable key map on the other. Okay, we have to visualize like that. Okay, and here how we are visualizing is we are considering it as vertical alignment, and this 0 is this 0, 0, 0 is adjacent with the 4. Okay, 1, 0, 0. This 0, 0, 1 is adjacent with this 1, 0, 1. 0, 1, 1 is logically adjacent with 1, 1, 1. 0, 1, 0 is logically adjacent with 1, 1, 0. Like that we have to consider in the stacked numbering version of the 5 variable key map. In the mirror image version of the 5 variable key map, whenever we are folding the 5 variable key map at the half, okay, we will get the mirror image version. Okay, mirror image version, and the logically adjacent cells forms the mirror images. Okay, and we can group those logically adjacent cells are the adjacent columns. And in the stacked numbering version of the 5 variable key map, we are placing one 4 variable key map at the other, okay, in the form of stack. Okay, and we can consider those columns as adjacent. Okay, those columns as adjacent. Vertical alignment of two 4 variable key map. Whenever we are considering two separate 4 variable key maps, we can consider this A bar is equal to 0, A is equal to 1. This A bar is equal to 0 for the first half of the key map, and for the next half of the key map, we are considering A is equal to 1. When you see the truth table of 5 variable key map, let us consider a 4 variable key map which ranges from 0 to 15, and another 4 variable key map ranges from 16 to 31. For these values, your binary value will be 1111, and for this it is starts from 10000 to 11111. So the MSB bit for these values, the MSB bit for this value, MSB bit for this value is 0. Okay. MSB for this key map is 0. Okay, 0. And for this, it is 1 because it is starting from 16. Okay, 16 means what? 1 0 0 0 0. Okay, here 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16. Okay, which ranges from 16 to 31. We are writing the staggered numbering version of the K-map in this way also. Okay, we can consider two separate K-maps, and for the first K-map, okay, whose MSB is 0, we are writing A bar is equal to 0 above that, and for the next 16 minterms, we are writing the MSB as 1, and other values which is same as of the 4 variable K-map. Okay, for the first one, and the next K-maps MSB we are considering it as 1. So we have to number that from 16 to 31. In this way, we have to write a vertical alignment of 2 4 variable K-map. But here, I am not writing vertically, okay, since I cannot explain it properly. Okay, I am writing it one after the other. Okay, but consider it as vertical alignment. Okay, I am writing considering this lower K-map, okay, with the higher one above the other. Okay, then you can consider this column is adjacent to this column is adjacent to this column is adjacent to this, and this column is adjacent to this. I hope all of you are getting. Okay, in this vertical alignment of 2 4 variable K-map, we are writing two separate 4 variable K-maps. For the first lower 16 bits, we are having the MSB bit as 0. For the next higher bits, we are having MSB bit as 1. So for the lower 16 cells, 16 minterms, A bar is equal to 0. A value is 0. And we are writing the K-map, okay, with the minterm 0 to 15. Okay, that we know how to write or how to enter the decimal notation for that. And for the next higher half of the truth table, okay, for the next minterms from 16 to 31, we have to enter like this: 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28, 29, 30, 31. Okay, and here you have to write A is equal to 1. Okay, by considering A is equal to 1, we are writing the minterms in the squares. Okay, we are including this A is equal to 1. Okay, we are considering the 16 binary value for the MSB bit 16. Okay, and then we are adding that to the minterms. Okay, BCDE values. 16 plus 1, 17, 16 plus 3, 19, 16 plus 2, 18, like that. Okay, and we'll solve some examples on this 5 variable K-map. The first example is simplify T equals f of A, B, C, D, E. And then these are the minterms whose output is logic high. Okay, now we have to write a 2 4 variable K-maps. For this first 4 variable K-map, A bar is equal to 0 because the 5 variable truth table will be having 0 0 0 to 0 1 1 1, first 16 values. For the next 16, we are having 1 0 0 0 0 to 1 1 1 1 1. The same values we are representing in the K-maps. That's all. Okay. First K-map 0 to 15. Next K-map 16 to 31. By considering the MSB bit A is equal to 1. Okay. Now here we have to consider the logical highs for the respective minterms to write, and after that we have to think for grouping. Here the minterm 0 to 8, 10. These 4 minterms are logically adjacent with the minterm 16, 18, 24, 26 because if you are placing the K-map, this K-map on this, the right half of the K-map is sliding over on the left half of the K-map. Okay. Then the columns are logically adjacent. So the 0, 2, 8, 10, 16, 18, 24, 26 all are adjacent. So we can have, it forms an octet. Since we can form it as an octet, 2 power 3, the 2 power 3 cells we are grouping, that is equal to 8 cells. So how many variables we are having in the function? 5 variables. 5 minus 3. 5 means number of variables in the function. We are grouping 2 power 3 cells. Then how many variables we will be having in the term? 2 variables. Okay. Now here, since our minterms are both are in both the K maps, a bar equal to 0, a is equal to 1. We are eliminating variable a. Next, see for this row and these columns. This row, in both the K maps, BC value is 0, 0. Okay, here 1, 0. So here C value remains same, B value is changing. So we are having C bar. Okay, and from these two columns, here also same thing, we are having 0, 0, 1, 0. Because we are considering a 4 variable K map with a lower variables values remain same for both the K maps, but MSB is changing. Okay, and next for these columns are also logically adjacent. So 0, 0, 1, 0, here the variable D is changing. So we are eliminating D and we are keeping E. So E bar. What is the term? C bar, E bar. Okay, this is the term we are getting when we are simplifying the min terms 0 to 8, 10, 16, 18, 24, 26. Next, another example. Here we have to write two 4 variable K maps. On top of these two 4 variable K maps, we have to write the MSB bit values, binary value. And after that, we have to write the decimal notation for both the K maps. For this first leftmost K map, we have to enter from 0 to 50. And for the next K map, rightmost K map, we have to consider the MSB bit also to write the decimal notation in the cells. Next, we have to check for the logical adjacencies and we have to form a larger group possible. Now, we can consider these two K maps and check for the logical adjacencies. Okay, here this 20, 21, 23, 22 forms one quad. 0, 1, 4, 5 forms another quad. Okay, and 30, 31, 27, 26 forms another quad. And 28, 24, 30, 26 forms another quad. Okay, and we have to think about 13 and 15. Okay, we can group this 13, 15. We can group this 13, 15 with 13, 15, or we can go for 15 and 31. Okay, 15 and 31. And now 0, 1, 4, 5 forms one group. 20, 21, 22, 23 forms another group. 31, 27, 30, 26 forms another group, which is a quad. 28, 24 should be grouped with 30 and 26, which forms another quad. And now this 13, 15, this 13, 15 can be grouped with this 13, 15 can be grouped as a pair. Okay, this 13, 15 can be grouped as a pair. Okay, if you are grouping only 13 with 5, again we have to group this 15 with 31. So we are grouping it as a pair. 13, 15 forms one pair, and then we are getting the product terms like this. This can be 28, 24, 30, 26 can give us. It belongs to the K map whose MSB is A, B, and then from these two columns, we are getting E bar, A, B, and then E bar. Okay. Now for this we are having A, and then B, and then D. Okay, D. Next, for this, since the A value is not changing, it is A. Okay, this we are grouping in only this K map, only in this K map. So we have to consider A, B bar, C. We are eliminating this DE variable because the D variable, E variable are changing. A, B bar, C. Next, we can group this 13, 15. And what you will get? You will get A bar, okay, A bar from this K map, and then BC, and then E. Okay. Next, for this group, for this quad, we are getting A bar, and then B bar, and then after simplifying these two columns, we are getting D bar. Okay. The final expression contains all the terms because in this all are unique. Okay, you can make this 4, 5 with 20, 21 also. Okay, these are logically adjacent. If you place this right K map on this, sliding over on the left K map, then this 4, 5 is adjacent with 20, 21. Okay, so we can group this 4, 5 with 20, 21 also. So we are having the term 0, 1, which is unique. So we have to include this term. This 13, 15, 15 can be grouped with 31, but 13 can also be grouped with 5. But we should not leave this midterms, which is essential. So we have to include this A bar BC. Okay. And this 28, 24, 30, 26, where 28, 24 are logically, 28, 24 are unique midterms, okay, which cannot be grouped in any other way other than this. So we have to include this. This one also we have to include because 31, 27 is unique. And this one also we have to group because here 21 midterm is unique, which can be combined in only one way. Okay, 20, 28, we can group it as 20, 28, 22, 30 also. But the midterm which is unique here is 21. Okay. We can, if they ask you to write all the prime implicants, we have to make a larger group possible by considering all the midterms. Okay, all the possible combinations of larger groups possible we have to make. Okay. So for the last final expression, we have to include all the terms. Next, these are the multiple choice questions. Please try to solve these. Okay. And try to solve these assignment questions. This is simplifying the 4 variable function. This is simplifying the 5 variable function. And I have given the problem which is in the non-canonical expression. You have to convert this non-canonical form into a canonical, and after that you have to simplify using the K map. Okay. Since it is a 5 variable function, it is difficult for us to simplify using the algebraic method. So we are going for the Karnaugh map. Convert this non-canonical expression into canonical and write the decimal notation of that. And after that, write the K map and simplify. In this session, we have studied about the 4 variable and 5 variable K-maps, and we have studied how to write 4 variable K-map and how to notate them using the decimal values and how to group them. Okay, and we have studied 2 5 variable. We have studied how 2 ways of writing the 5 variable K-maps. One is mirror image version, and the other one is stacked numbering version. Okay, we can go for any of the method, any of the version, stacked numbering or mirror image version. But the numbering is only different for the stacked numbering version, mirror image version. But vertical alignment of the stacked numbering version is easy for us to understand. So whichever version is easy for you, you can do that. Okay. And we have solved some examples on this 4 and 5 variable K-map. Thank you for listening to the session.